Hey guys, um, video quality is probably going to be somewhat low, and I'm probably going to be somewhat anxious because this is one of the first things I recorded. Um, but this video is going to be about um, basically arguing for a subjective notion of Occam's razor that is very different from current philosophy of science approaches. Um, I'm exhausted in case you can't tell, but I think the train of thought will still be pretty followable. Um, so basically, um, what I mean by an objective interpretation of Occam's razor, these tend to involve some kind of notion that the reason simpler theories tend to be truer is some sort of preference on the part of the universe to minimize simplicity. It's obvious why somebody would look for such a thing, including the fact that the very complex phenomena in the universe can be reduced to simpler laws, although and the fact that there's lots of physical principles of work minimization. Fundamental particles seem to follow their most simple path, which is it's a big principle in optics, for instance. The problem with this is that I cannot genuinely explain the level of independence of Occam's razor. That Occam's razor can be applied to domains of any level of complexity because a preference for simplicity on the part of the physical universe shouldn't explain why Occam's razor would apply in economics or the social sciences, where we are talking about the behavior of conglomerations of trillions and trillions of particles. There's no reason this simplicity should be transferred over in that case. So what I'm going to do instead, and another problem is, although yes, given a certain set of phenomena, we should seemingly prefer a more simplistic explanation. If Occam's razor was genuinely the result of a preference for simplicity on the part of the universe, it should also have value predicting phenomena. It should be able to shave both ways, and indeed, unless we're to accept ideas that Hawking has been interested in of a zero energy universe, or David Peirce's idea of a zero information universe, there seems to be little way that the universe itself is optimizing for the maximum simplicity, which would be nothingness. So Occam's razor, it doesn't shave both ways. It shaves theories to fit phenomena, but it does not shave phenomena to fit theories. Which is likely what would happen if it was predicting what the universe was actually doing. But the level of independence is an even more important issue. So what I wanted to do is basically propose a subjective notion of Occam's razor, where I'm going to claim it's not the fact that these simple theories are simple that is evidence for them. It's the fact that such a simple theory could be discovered by a human knower that is evidence for the theory. Which sounds like a rather strange notion, but what I'm going to do is I'm going to do two things. I'm going to, first of all, talk about viewing scientific theories as processes of information compression. And then we're going to be able to see why the delineation between theory formation and theory assessment, which typically happens through experiments after a theory is formed, is not actually as strong as is typically thought. In other words, the process that a scientist goes through to find a theory actually demonstrates something about the truth of the theory. But to shortly sum up the value of what's going to be said, so Einstein actually claimed he could have known general relativity was true before any experiments had been done, and he also claimed he claimed that the theory was so beautiful and so simple that it had to be true, which sounds like a very irrational notion. But I'm going to the arguments I'm going to be given, they're actually going to explain why these apparently aesthetic principles of theories have epistemological value. And they're going to have some very interesting implications because they're going to predict that actually an AI which brute forces things based on massive amounts of computational power will not actually be able to replace a human discoverer and will in fact mislead. So let's get started. First of all, the reason I think simpler theories pan out to be true is I first of all think it's just a heuristic, not a law, which is how this principle is normally treated anyway. But I think it's a heuristic demonstrating the existence of internal evidence on the part of a scientific discoverer. This is a little bit of a strange notion, but basically, I think that to discover a simple theory of these phenomena, often it would be really impossible computationally if some kind of unbounded, unrestricted search was actually occurring, so that the discoverer must actually have a lot of internal evidence telling them where to look in the first place to have found this. Why do I think this? Well, I view scientific theories as acts of information compression. They're time-space trade-offs, sort of similar to, say, if you're compressing a file, you have to take all this data, reduce it to simpler rules, and then you save kind of some seed state of the data, and given the simple rules and enough computing power of time, you can actually get back the state that was being compressed. Well, what scientists do is they take an immense amount of information about the universe and they compress it into a simpler theory. And in fact, to have an entirely deterministic theory of the universe would definitely be to have a complete compression of it, where we would be able to take the initial state of the universe, some laws, and if we had enough computing power, be able to know everything else there is about it by unfolding this initial information. The interesting thing about viewing theories as acts of information compression is it brings to the fore how seemingly impossible it is that humans have been able to discover these theories in the first place. Yes, it is amazing that the universe can operate by such simple rules, but it's far more amazing that is computationally possible for somebody like Newton or Einstein to have compressed that much information about the universe somehow successfully. In fact, it doesn't make really any sense that humans are able to do that. And in fact, we don't fully know why humans can do that, but it must be partly, we have to at least lean partly on a Kantian explanation where, to the extent that we have a valid epistemology of the universe, our mind is formed to be universe enough alike that we can start looking in the right places, which makes sense in terms of evolution. If we weren't able to do that, we wouldn't have been able to survive. So the universe meets us halfway because our minds are already by nature adapted to look in some of the right places. Theories on the part of humans, they're never the result of brute force, but what I actually wanted to also bring to the fore is I'm going to give good reasons to think that obviously this varies between humans. Some humans have more insight, see deeper patterns, and things like this. And actually, I'm going to give evidence that this internal evidence is a lot more important than assumed. So first of all, the fact that a scientific theory is very simple, it indicates that this immense amount of information compression has occurred. And when we look at what information compression is, it involves finding patterns in data, and only to the extent where patterns that are very good at describing the data get found can this compression happen. It's easier to understand why a computer with massive amounts of computing power might be able to do this. It's not easy to understand why a human being can. And in fact, part of the explanation must be once again, we do not do this unbounded, unrestricted search when this happens. But the reason I'm making this analogy, when we look at this thing as compression, what's obvious about it is to find a theory involves internal evidence, and we have to have patterns before the theory is developed in order to get the theory. This happens to varying degrees of strength, but the simplicity of a theory is actually an indication of the amount of compression that has occurred, and thereby it's an indication of how many patterns were spotted, but it is also an indication that the human who found it must have started out looking at somewhat at the right place. They must have had some sort of internal evidence guiding them, because it should not really be computationally possible. Sorry if I'm being repetitive. But now, why does the process a scientist goes through to find a theory matter? Why would a theory found through brute force be less trustworthy than the theory found through insight, which is part of what I'm claiming? Well, although this is kind of strange to think about, I'm going to give reasons to think that a lot of experimentation takes place before a theory is found. A physicist, for example, to find a correct theory of physics, they do a lot of thought experimentation, mental simulation to verify and find this theory and make the correct modifications to eventually reach it. Now, the really interesting thing is I think this can be treated as akin to physical experimentation, where just like if there is a lot of physical experiments that fail, the certainty of a theory goes down. This mental experimentation must be treated the same way. Why would this be? Well, I'm assuming that the reasoning process used is correct, meaning we're going to make the generous assumption that the simulation done by the physicist in arriving at the theory was correct, because if they reached the theory based on the wrong reasoning, then it's probably not true anyway. But if they did find a theory that fits the domain, then to the extent that any reasoning, any thought experimentation, any simulation that occurred was useful in finding it, they must have successfully abstracted the right parts of the physical domains modeled in order that these simulations could act just like a physical experiment would. Otherwise the modeling would not have been correct. Sorry, I should write a script for these things because I can kind of be repetitive or, yeah. But anyway, so yeah, to the extent that the experimentation that arrives at a theory is correct, that means we accurately simulate the subject matters modeled. So the modeling can be treated as similar to a physical experiment. And now let's look at this from a Bayesian perspective, where not only are we testing out is a single theory true, but we're looking at is a family of theories useful, or does it have a high chance of being true? We can every experiment can also be a test of this meta hypothesis. What would happen if a physicist who eventually brute forced a theory by just trying things over and over and over again did this, and what would happen if a physicist who started looking for a theory based on some genuine insight did this? Well, the second one, even no matter how descriptive the theory turned out to be, how accurately predicted phenomena, their internal evidence for the theory would have dropped a lot from the fact that, imagine, I guess a good analogy, imagine somebody did come up with a classical replacement for general relativity, but it took thousands of experiments and modifications to find it. Well, then we would have very little reason to trust it, because the meta hypothesis that this class of theories would be useful in general would have been mostly exhausted, even though a predictive theory would have been found. Whereas Einstein's relativity, we know he knew something about the universe because he came up with it entirely in his head and never needed to modify it one bit. And once we understand that this does not just apply to external experiments and that this is already happening from a Bayesian perspective, this is already happening throughout the process of experimentation done by a discoverer, then actually, characteristics of theories, they can be the process through which a theory is discovered is an indication of the amount of internal evidence that a theorist has, which we know unless they somehow just get lucky, they must have had a lot to find these theories. So not only, part of the reason I'm bringing this up is Eliezer Yudkowsky. He wrote a really interesting essay claiming that Einstein already had reasons to believe in general relativity once he had discovered it, because he must have had enough insight and internal evidence to even find it that he could also partially verify. But the interesting thing is he doesn't recognize that this internal evidence is partially transferable. But once we understand that a theory is information compression, there's something kind of akin to, I guess the only thing I can really compare it to is cryptographic proof of work. Now, if what I'm saying is true, it actually has a lot of relevance to computer mediated discovery, where there's lots of people claiming as long as we have enough computing power, we can discover anything a human mind can discover. Well, actually, first of all, finding an explanation of phenomena that describes all of them, it's not necessarily much of an indication that you have the right explanation. There's probably an infinite number of ways of describing how the universe works, for example. And there's also an issue of how to describe it. I guess. Even to have a simple physical theory of something, is this very meaningful? Well, one thing to understand is any complex information can be compressed to simpler information as long as you're really good at finding patterns. Even completely random sequences of data, a supercomputer could compress into a very simple package. And yet, this would not indicate any kind of insight. So my prediction about what will happen with AI mediated discovery is if these machines are just brute forcing things that look like intelligence, they will produce simple predictive theories that will not actually work, because in my viewpoint, Occam's razor indicates something about the process of the knower in a context of limited computing power, where in that context there must have been insight to have arrived at theory. It's a strange perspective, but there's lots that's useful about it. It definitely can explain more of the rationality of scientific geniuses, where people like Kuhn and stuff like that have claimed Galileo ultimately had no reason to have faith in his theories, although they ended up getting confirmed. I just wanted to leave you with those thoughts. I think that's all I had to say. Except there's already stuff like this that's happening in one area where supercomputing has been applied, which is in the financial markets. If you look at work by David Bailey, he does a similar thing, but in a lot narrower of a field, where he's looked at this strange phenomena where supercomputers, they'll find very retro-predictive, simple models of financial phenomena that look like good theories, and then they won't have any predictive value. And he's basically given a similar explanation where he treats every computer simulation of the market that is done as an experiment, and the sigmas of certainty go down the more that is done, so that supercomputing is not actually as useful as assumed. And he's kind of shown that this actually can predict the rate of failure of these theories. So there's already verification of this in one area, quite interestingly. But our epistemology of science, it needs to be partly about how we figure out the universe and partly about how the universe makes us halfway, because that's what it takes to find a successful theory. So just wanted to leave you with those thoughts.